Okay, perfect. So, hello, my name is Michael. You might remember me from the Go Crazy project. This talk is not about Go Crazy, but while I have you, I'm going to do a quick status update. So you might remember that I wrote this rsync server like many years ago. I had a talk at this meetup actually about rsync. Some of you were there. By now, I'm happy to report that the rsync project is like entirely written in Go, and now it supports all of the directions. So early on, it was only a server from which you could download files. Now it's a client and server, it's a sender and receiver, and it has like all of the APIs and interfaces. With regards to the theme of what's new in Go over the years, there are actually a couple of really cool new features that were introduced that I'm now making use of in the rsync project. For example, there's this traversal safe API called os.root, which was introduced first in 124 and then extended in 125. If you haven't used this and you have any Go program that interacts with untrusted paths, like maybe a network server or something like that, definitely check it out, because this is an API that's kind of like a change root. Like it allows your program to only work with files within a certain directory and they cannot escape. And similarly, and then lastly also, the other cool new API that was introduced that Go Crazy rsync now supports is Go's io/fs.fs, like a file system abstraction API for custom file systems. So this means that not only can you serve files from your disk, you can also serve files from a database or entirely generated, synthetic, debugging, eBPF programs. Anything is possible. All right, with that advertisement out of the way, let's get to what's going to be new in Go 126. So on the slide, I've put it like very diplomatically. Go 126 will be released in February, this much I can say. I can also leak that the plan is to release it in 5 days from now. So you'll know it. you heard it here first. So of course, there's a lot of changes in 126, and I'm not going to go through all of them. As usual in this talk, we're going to pick out a couple of like cherries that we want to highlight. And in this presentation, I'm going to cover the new built-in. I'm going to speak about the go fix command, very briefly about the green tea garbage collector, which was actually already released earlier. And then we have two more experimental features that you all can help stabilize, try out, and test. And that's going to be experimental SIMD support and goroutine leak profiling. So before we jump into this laundry list of features, how do you actually upgrade to this release? I mean, right now you can't because it hasn't been released, but there are release candidates. So 126.0 RC3 is the current release candidate. So you could also try out a release candidate if you don't want to wait 5 more days. And the way to get this release is either you can just go to go.dev, download, and just install it on your computer as usual, right? But there's also the way where you just edit your go.mod file. And this go.mod file, you can edit it either with a command like here, go mod edit -go, changes to Go language version, or you just open it in your favorite text editor or IDE, and then you just change the language version from, I don't know, 125 or whatever you have to 126. And then the next time you build or test or install or whatever, Go will automatically download this version for you and use it. This is a feature called toolchain management, and there's a blog post about it, which I've linked here if you want to learn more, or turn it off if you're in like a heavily restricted corporate environment. But I think it's like the most convenient way to update to new Go versions, and I use this all the time. All right, so before Go 126, consider the following code. This is like very standard JSON marshalling code. We have a type defined that's called person. It's a struct type. It has 2 fields. The first field is a name. The second field is an age. Now, the age is of pointer type. This is important because here it could be that the age is unknown or it is known, right? And in one case, it is nil, and in the other case, it's a valid pointer to some data. Now, let's only consider the case where age is actually non-nil, where it's actually set. So it will end up on the wire. We have this person JSON helper function here, which takes a name and the time when the person was born, and then we just like very crudely approximate the years that this person is old. And we store this in the variable age, and then we call JSON.marshal with a struct literal of the person struct with name is name and age is pointer to the age variable. So far, so good. Every one of you who has worked with different data formats like JSON or protobuf or whatever, it's very common that these represent presence as pointers. So you will have nil pointers or non-nil pointers. And it's always been like a little annoying that you had to write age, like pointer to age, and define an extra variable for this, right? Like, why couldn't you just put year since and take the address of that, right? And now it's possible. So in 126, you no longer need an explicit assignment. You can just wrap your expression in new, and then you'll get a pointer to this, right? So that's really all there is to it, right? It's like a little quality of life enhancement. It makes these large literals a little bit nicer to write and read and capture when you're scrolling over them. All right, let's move on to the go fix command. So before we talk about go fix, we need to talk about what is a modernizer. A modernizer is a special kind of Go analyzer. Now, what's an analyzer? An analyzer is a program that uses the Go/analyzer package. So there's like a collection of packages that make static tooling like this a lot easier and possible even, I would say, in Go. Now, modernizers are a certain class of analyzers. And first of all, the purpose is to modernize your code, as the name implies. But there are a couple of requirements for them as well. So all of the fixes that the modernizer, or all of the cases that the modernizer flags, there must be a fix attached to it. Like, you can't have a modernizer that just tells you, hey, this is wrong, right? It also needs to tell you what to do instead. All of the modernizers have to produce safe fixes. So if you decide to accept the modernizer's suggestion, your code afterwards will still compile and work exactly the same. And if not, then that's a bug, right? And please report it, and then we'll fix it. Yeah, I don't know what's up with that. Our hosts should figure this out. Like, I'm just dialed into this thing.
Please, we have one screen.
Yeah, I'm a little bit worried about this.
Wait until this is the short time. Battery? In the battery? Yes. Should we maybe? No, yes, please update.
Yeah. We'll do the update later. Okay. All right. So let's get back to it. Modernizers. The suggested fixes, they must be safe. And here's an example of what the modernizer could do. So if you have a for loop and you have a variable and you just want to like run it a couple of times, you could write it as for I : = 0, I less than 3, I++, right? It's like a 3-expression for loop. We're all very familiar with this. But when you just write this into your editor and you use a new version of Go, your IDE will actually tell you, like, it will do the little squiggly lines and be like, hey, actually, did you know there's range over int? You can write this a little bit more nicely. You can say for I : = range 3, and then you don't have like the 3 expressions and all that noise. And up until now, you could just like apply these in your IDE, right? Like, if you open Visual Studio Code, maybe you have like a lot of yellow annotations there, and you're like, oh man, I really need to like click through all of these lines. And that's just very annoying. So since Go 126, there's a new Go tool subcommand called go fix. And you can just run this like you run go build or go test, right? You just do go fix ... and it just fixes all of your code, right? Obviously, it doesn't remove the blocks, it just modernizes it, to be clear. So the go fix command, like, I would love to say it's actually new, but it's not strictly speaking new. Just sort of as like a little interesting historical anecdote, the go fix command was actually one of the first commands that Go shipped with in the very early days. So before Go version 1, it was the case that often the team would want to make changes to the compiler and toolchain. And then these changes would result in the code that had been written to no longer work as is, right? And that was before the Go 1 stability guarantee. So back then, it was very usual that when you made a change to the compiler, you would also add a fix rule. And then the users who were like on the release candidate version of the compiler could be like, oh yeah, just go fix, see if it works. If it doesn't work, just add a little thing here. But usually go fix would fix your code, right? And then with Go 1, which included the compatibility guarantee, that command was obsolete, right? Because you no longer needed to fix your code because the code you had would just always stay working. Right. So now we have this command available and we repurposed it. So now it's used for modernization. All right. So if you want to learn more about this, this is largely Alan's work. Alan Donovan gave a talk at GopherCon 2025. This talk is now uploaded to YouTube. It's called Analysis and Transformation Tools for Go Code-Based Modernization. I'm, of course, also going to share these slides later so you don't have to note anything down. All right. The next feature I want to speak a little bit about is the green tea garbage collector. So Go to 125 actually shipped with this already. So it's not a new feature in 126, but it sort of transitioned from being in the experiment stage to being enabled by default. And to remind you all what this is about, so if you have a program that does a lot of memory allocations, then you might see a reduction in garbage collection overhead of between 10 to 40%, depending on what CPU you run this on. If you have a more modern CPU, such as anything after Intel Ice Lake or anything after AMD Zen 4, and also including, you will get an extra 10% reduction. And why is that? Because these processors have like the vector processing instructions that you need to make this new architecture like fully play out its strengths. So essentially, like the green tea garbage collector is like there's a blog post here where you can read a lot more about it, right? But essentially, it's sort of like changing the data structures in the Go garbage collector to make it so that it is much more tuned or it's much more feasible to use the SIMD algorithms on top of that. And the current algorithm that we have here is not necessarily the best and the final and the last one. Like the team is very much still developing this technique, right? Like this is an open area of research. And just today, I actually saw a presentation from Michael Knischek, one of the people who's like leading the garbage collection work. And like he had this whole presentation about like, oh yeah, this is what we tried. There's a couple new ideas here and this and that. And so expect to see future improvements on this. I see this as very much sort of just laying the foundation, right? Like this is just changing the data structures and the first version of a good algorithm. And then we can sort of iterate on that, right? All right, and more generally, this is not the only case or the only place where SIMD is used in Go. SIMD, in case you hadn't heard of it, stands for Single Instruction Multiple Data, which you might wonder, what does that even mean, right? But if you have like a computer, typically you process byte by byte, right? If you take the length of a string, you would need to scan it until you reach the zero terminator or something. That's like single instruction, single data, but there's also instructions that process multiple pieces of data at the same time, right? And this is like very common in, for example, image processing, or these days, of course, in AI, right? So the need for SIMD has always been there, but it wasn't as pronounced as maybe is today. Like the high performance computing people have always been like, yeah, we need SIMD in Go, and everybody else was like, but now everybody needs it. All right, so what shipped in Go 126 is the first half, I would say. What shipped is a low-level architecture-specific API and support for all of these intrinsics. And what will come later is the high-level portable vector API. So if you're thinking, what? This is similar to the split between syscall and OS. Like syscall is like the low-level Linux system call kernel-specific interface, and an OS is a nice high-level API so that you don't have to learn about syscall, right? And it's similar here with the SIMD stuff. Like what you can do right now is if you are sort of translating or developing a SIMD algorithm like instruction by instruction, now you can do that and the Go compiler will compile it for you. But there's no such thing as, for example, the highway package. If you're familiar with that in C++, highway is like a high-level portable vector API, and it compiles down to like all of these specific things. And by specific, I mean that 126 only actually included SIMD/Arch SIMD, which is the package for like the architecture-specific stuff, only for AMD 64, because this is very CPU-specific. Now, there's also other processors, of course, and processor architectures that have vector instructions, like ARM 64 and the Neon instruction set, for example, and there's probably a couple of others. But you have to start somewhere, and for now, 126 only includes AMD 64 support with 128, 256, or 512-bit vector types. So depending on what it is that you're looking to do, maybe you can do it or not. There's an issue here, that's issue 73787. That's the proposal issue for SIMD support. There's like a lot of content in there. You can read through it if you want to learn more. Or yeah, just give it a try. Like if you're one of the few people who actually want to use SIMD, give us some feedback on this. All right, and then the last feature I want to talk about is an experimental feature called Goroutine leak profiling. So this is actually, I want to say like almost sort of a spin-off of a larger effort, and the larger effort is about deadlock detection. So there's a research paper, including code, from Aarhus University and Uber. And they have changed the Go garbage collector such that it is able to detect deadlocks. And now in 126, the first sort of piece of work that made it into Go proper is an experimental feature the Go routine leak profiler, which also uses this infrastructure in order to allow you to track down where your Go routine leaks are. So for example, if you're looking at your, I don't know, Grafana dashboards with like a lot of Prometheus metrics and you see that the Go routines are steadily only ever going up, you have a problem. And this leak profiler will tell you where exactly is that thing that creates all of these Go routines without cleaning them up. Now, I have to admit, I haven't actually had the chance to try it out. So if you have tried it out, let me know if it works well. And if you want to try it out, you can set the Go experiment variable, environment variable, and you set this before compiling Go, right? So there's like Go debug for things that are always compiled in, and you can just enable and disable at runtime. But this is one of the things like you need to compile Go with that enabled. It's like very deep in the compiler and runtime. But luckily, compiling Go is not that hard. Like, you can just download it, and maybe like a minute or two later, you will have a working Go toolchain on your computer. All right, so of course, as I mentioned, there's a lot more in Go 126. You can go to go.dev/doc/Go126 to see the full release notes. And with that, I'm going to say thank you so much for your attention and enjoy the latest release of Go.